Hello and welcome to Func Prog Sweden. We are back finally. First, I would like to welcome all new participants to Func Prog Sweden. Welcome. This is the meetup where we explore functional concepts and functional programming languages like Clojure, Erlang, Haskell, Elixir, and more. And also like to welcome all recurring viewers. Welcome back to Func Prog Sweden. Thanks for coming back to us and watching us again. With that, we'll look over to the agenda. So today's agenda, as always, I'll do a short intro by me, Magnus Sedlacek. And then we will hear a presentation called Witchcraft, Lessons from Porting Monads to Elixir by Brooklyn Zelenka. Brooklyn is a distributed systems researcher and editor of the UCAN auth spec. She founded the Vancouver Functional Programming Meetup and has worked on standards spanning distributed virtual machines, data privacy, databases, wire formats, key agreements, and others. And then when Brooklyn is done, we'll have over to Painless stretchy web apps using shorthand notation by Edward De Jong. Edward is an old-timer. He's been around for a long time. He started programming in high school in Pasadena in California on an IBM 1620 punch card laptop, or not laptop, maybe it was like a mainframe. Later used the UNIVAC 1108 JPL on the IBM Systems 370 at Caltech, and then graduated from MIT with a bachelor's degree. He progressed to HP, mini computers, then IBM, and then Apple Macintosh, personal computers, and finally mobile devices and the web. He was the lead programmer on WordStar 2000, IBM DisplayWrite 5 Composer, Flying Colors, Dragon Ball Z, Ultraman Paint program, and more, and currently has worked on over 90 iPhone web apps. Wrong way. Then in the end, we'll do a post-show chat on the Discord server, so if you want to ask more elaborate questions to the people presenting, please join the Discord server and take your opportunity to ask more questions. But first up, we would like to thank our video sponsor, AuthorBeat. AuthorBeat is an IT consultancy company working with functional programming, and if you want to know more about AuthorBeat, check them out on their webpage or on social media. And then the schedule for the coming meetups. In August, we are back. We haven't set a date, but we'll be back, and we'll have 1 or 2 presenters. Then 10th of September, we are running the next meetup, again live or on digital only. And then in October, we will be at Kivra in Stockholm. So if you are around in Stockholm in October, 8th of October, make sure to join at Kivra. And of course, you want to support the Func Prog Sweden community, head over to Meetup and join our group, or make sure to subscribe here on YouTube if you're watching. And of course, join the Discord server. You'll find the invite either in the Meetup page or on the YouTube spec, if you check below here. If you have questions during the presentation, please use the chat on YouTube or ask them on Discord, and I will convey them to the presenters, or join the Discord server afterwards, where you can ask more elaborate questions. With that, let's get started, and welcome to our first presenter, Brooklyn. Welcome to Func Prog Sweden.
Thank you so much for having me.
Yeah, you're warm welcome. We are very much looking forward to your presentation. So the stage is yours. Welcome.
Great. Awesome. Well, again, thank you so much for having me. I always enjoyed talking about, especially Witchcraft, especially this work, which in some ways shifted the course of my career. And we'll talk a little bit about how it came to be and some of the history here. But by accident, I haven't actually gone and dug through like the original commits, but this is, I believe, the 10-year anniversary of Witchcraft. So it seems like a good time to have a retrospective on the project. So I'm going to be talking about an Elixir, a suite of Elixir libraries together known as Witchcraft, and sort of the tagline for them is bringing Monads to Elixir. So there's this classic Painless quote where he says that a language that doesn't change the way you think isn't worth learning. And that's true, but also, you know, sometimes we're not writing an entire language. Sometimes having a library change the way that you think can be helpful as well. And especially in functional programming, where there's not just one monolithic thing that is functional programming, there's all of these subdisciplines and that are ultimately compatible, but often a particular language will focus on one. And so without having to learn an entirely new syntax and an entirely new way of, you know, tooling and way of interacting, sometimes it's useful to change the way you think about things in a lighter weight way. So my name is Brooklyn Zelenka. You can find me most places on the internet as Xpeed. And as mentioned, I'm an independent distributed systems researcher. These days I work a lot in an area known as local first. So computing where it's not local only, but by default, everything happens directly on your machine. And then if you need to go to the network to do synchronization or some heavier computation or something like that, then you can do that, which then often leads into a related peer-to-peer space. And lately been focused on, and this will actually become related at the very end, I think, end-to-end encryption capabilities, CRDTs, and virtual machines, especially WASM. And I wrote a bunch of Elixir libraries over the years. Sometimes people have called Witchcraft Haskell fan fiction, which is not inaccurate. So, but I've also written others that are less trying to bring things from this other ecosystem in. So Exceptional is probably the big one, which was bringing railroad exceptions. So almost like the either style, if you're familiar with those from Haskell and some other languages, before Elixir had the with syntax, which we'll probably touch on a little bit later. And frankly, I had a ton of fun writing these libraries. Yes, I founded the Vancouver Functional Programming Meetup, ran that basically until the pandemic hit. It was in person. And that went from, maybe about 2012 to 2020, and we should probably get that started again. So maybe this will be my inspiration to get that going again. So what is Witchcraft? So I started learning, I became aware of Elixir probably around 2013 or so. Prior to that, actually my first programming job, the first language I learned was Clojure, and then Scala and a few others, as well as a bunch of imperative languages. And became aware of Elixir around 2013. And Vancouver has a lot of Rubyists, and thus Elixir appealed to them. And so we had a lot of people suddenly showing up to the functional programming meetup asking, hey, can we learn Elixir? So I thought, okay, sure, you know, let's take a look at this thing. And coming from, especially coming from Haskell, but to a lesser degree Clojure, Elixir didn't feel very functional to me. It had the immutability and the purity, but it didn't have a lot of the patterns that I was otherwise used to. And if you dig into the history of Elixir, this makes a lot of sense, right? They didn't even set out, so Elixir and Erlang are very famous for having this actor model for high concurrency. And they didn't even really set up to create something based on the actor model. They were just trying to solve problems at Ericsson. And they happened to stumble on something that looked a lot like the actor model, and they found out that that's what it was later. And so same thing with functional programming. They didn't set out to create a functional language. They just happened to fall into this functional-ish flavored thing. I figured we can fix that. So a lot of people were showing up. They wanted to learn Elixir. They wanted to learn Haskell idioms. What if we could blend the two with a language that felt at least safer to learn for especially Rubyists? And I've always found this to be like a deep irony, because Elixir has other than some high-level syntactical things, has very little to do with Ruby, like at all. But Rubyists seem to like it because it comes from this. A bunch of people that started on Elixir were from the Ruby community. So I figured, how hard could it be? And it turns out that it's a lot of fun, but a lot of work, So 5 libraries in this suite. The first one that we wrote was Quark, which was trying to show like the really classic FP stuff. And we'll talk about this a little bit more in a moment. But yeah, it ended up being 5 libraries instead of one giant monolithic thing, because they actually turned out to be pretty useful on their own in multiple contexts. So there are also some challenges in doing this versus, like, especially, we're going to talk a lot about Haskell here, obviously, right? So Haskell as a language and a runtime has certain guarantees about how it works, right? Its type system works in a particular way. It gives you a lot of safety. That, the classic line is, some addition operation won't fire the missiles, right? And you don't get that in Elixir, right? It's heavily side effectful. You're always calling between actors. It's very low on equational reasoning unless you're doing like really constrained things. It's simply typed. It has some bolt-on analysis with some extra tools, there's dialyzer, etc. But it doesn't really have something like deeply ingrained. They are working on a type system right now using set theoretic types, which is a newer type system coming out of academia. That's super interesting, but I don't believe it's actually shipped fully yet into the language. And at the time that I was writing this, they didn't even have support for things like automatic threading of errors. They now have a syntax called with syntax that has left pointing arrows and actually looks pretty much like denotation, only for exception or for error handling. So as I mentioned, this was for also people wanting to learn sort of both. So I started Quark. So it's called Quark because it's about the small independent things that come together. So the basic combinators like identity, SNK, fixed points, composition. So Elixir doesn't have a composition function, or at least not at the time. I think they still don't. They only do application. Started that around 2014. Bulk of the code and through most of these projects would have been about 2015. Quark saw production use from basically day one. So I got to use it directly in my job. So I was writing Elixir professionally starting about 2015. Yeah, early 2015. And it was just broadly useful. So being able to stub out arguments with identity, for example, is a really common thing. Being able to flip the order of arguments without having to write a new variant, pretty helpful. Things like that. And then in the wider set of libraries, I found out a few years later that apparently not really supposed to say who, but a large bank started using it in their trading platform, Witchcraft. So like the full with Monads and everything, which was a surprise to me because it started out really just as this like exploratory project that's mainly for teaching purposes. And then it ended up getting a lot of production, way more production use than I expected. So it's certainly not as popular as the web framework Phoenix or something, but a lot of people seem to want to write code in this way, even in other languages. As a general strategy, so I've seen a lot of these attempts to port from one language to another, and they're not always successful, right? Because they try to take really that way of thinking, so like that perilous quote from the beginning, and just apply them and impose them directly on the new host language. And it ends up feeling like these disconnected pieces that are not unified with the rest of the ecosystem. So having something that feels, even though it has these new idioms and these new ways of working, these ways that feel more like that host language was the strategy from day one. So how can we make this still feel like Elixir? How do we use the pipe operator to thread through arguments? So they have this, it looks like a little arrow that you then pipe through. The argument order is different than in Haskell. You're not mapping, often the mental model changes, right? In Haskell, you have a function that you map with an operator over some arguments. But you don't do that in Elixir. You pipe arguments through functions, right? So you have to rethink and sort of like pull apart your understanding of these guest idioms into the host language, and then reinterpret them for it. There were a bunch of just straight up missing features in Elixir for this style. So they have protocols, which are basically type classes, but without constraints on them. So you can create a protocol for a particular, let's say you want a functor, you get a functor, but monad depends on functor. They had no way of expressing that. So we had to port that into the language. Luckily, Elixir, for better or worse, better for me, maybe worse for them, has macros. And so you can basically, plug into the compiler and extend it as much as you like. And as an approach, we wanted to start small. So, adding a compose function and then grow those features out into the really, the intense things. So having arrows and fan outs and all of these things. I actually think that the arrow stuff was criminally underused in Witchcraft, because it seems like such, there's so much data flow stuff that happens inside of in Elixir. And this gives you a really concise way, a really crisp way of expressing those data flow operations that wouldn't depend on a particular library like or a particular implementation. So they have all of these data flow libraries that are even shipped by the core team. And so this would give you an abstraction over those. And yeah, so we use functions whenever possible. We heavily abused macros, and made sure that we wrote our macros as functions and then called those functions inside of macros so that we could test them easily. And we worked with raw AST, not with the declarative macros. It was all proc macros all the way through. The hard one for all of this is having a consistency with mental models. And a lot of that is how you actually express from the language level. And we'll look at some specific examples of this. And we wanted it, and we in fact tested along the way that we could use these with other languages, with other libraries in the ecosystem. And then it was obviously also focused around pedagogy, so teaching and approachability. So the docs had to be nice. They had to teach the concepts. They had to have examples and doc tests and all of these things. So it's almost like the docs aimed almost to be like a little mini lesson on these concepts at the same time, with, I would say, varying degrees of success. These all depend on each other. Quark at the bottom, we have operator, type class Algae, and Witchcraft at the top, consuming all of them. So Quark, as I mentioned, has all of your basic combinators, so S, K, and I. So even with just S and K, you can get all of functional programming, fixed points, various fixed points, automatic partial applications. We created some macros so that you could write def partial as opposed to def for your function, and it would automatically generate all of your partial applications. So Elixir is a variadic language, so you can have the same named function have multiple different numbers of arguments in it. And so this would generate functions that would return functions with a partial application in it. So with one of the arguments already pre-applied. Identity, flip, constants, etc. And I don't know how I really feel about point-free programming. So this is using only the composition operator. So you see this in Haskell, and is sometimes very, very elegant, sometimes difficult to debug. But we created a point-free operator. We'll talk a little bit about operators in a moment. And this was very broadly useful. We ended up using this inside of that other error handling library that's not in this monadic style at all, called Exceptional. I've seen this one because it just has the basics in it in a lot more projects than a lot of the other pieces. Operator, this is just a little utility library that we lean on pretty heavily inside of Witchcraft. Elixir chose to have a fixed number of operators, regardless if they're infix or prefix or the various fixities. They have this particular list and none others. And binding those two functions can be a little cumbersome. Like they don't really want you doing it, right? Unless you really, really have to. And that's fair, I think, right? Like we've seen in the Haskell ecosystem over time, people moving away from these operators. If you've ever looked at the lens library in Haskell, it does produce this really interesting mental model where you know what all of the different sigils mean now, but they don't, you really have to learn this really specific DSL now, right? So they give you a constrained set of them. I would say that the best decision that we made in operator is that you must have a named function, which Elixir doesn't enforce, right? So you must have a named function. And then you can just with an annotation above it, you go at operator, and then you say which operator it's bound to. And then it just generates the rest for you at compile time. Pipes, so again, Elixir has this pipe operator. I would say that that's the preferred way of doing things. Pipes are the best way of doing, of having something that's closer to an infix, because it is an infix, right? So you're always doing this piping through. There definitely are times when you want these other things, right? So we're going to talk about how we brought do notation into Elixir, like full-on Haskell style do notation, requires some of these, right? So sometimes it is helpful to have them still. Algae, so these are for algebraic data types, which Elixir doesn't have. It only has structs. So basically maps with a set number of keys in them, and actually under the hood, they're just structs with a special key that says, hey, this is a struct, like, you know, maybe don't only allow us to set certain fields on it, but you can actually work around that if you need to. It doesn't give you co-products. So there's no way of unioning two things together. So because it's a dynamically typed language, right, or very, very simply typed, they tend to rely on things like this in the top right, where you have you know, some symbol like just, and then some value or error. You'll see this all the time as error handling, but there's nothing preventing you from having any number of these tuples, right? And I've actually run into this as a major problem. There was like actually a blocker for me for a long time with some undocumented edge cases like this. Because you don't have strong typing, they can use whatever they feel like, any number of arities, you know, all of this stuff. And so having something that's a little bit more constrained where you can say, well, my options are just or nothing, and those are always structs, means that if I need to add more fields later, I can. It's extensible in a way that having a tuple isn't. You add another field to a tuple, your pattern matches fail. If you do it with a struct, you don't have that problem, right? I think this is the most broadly useful, despite Quark probably getting more, me seeing it in more places. I actually think this is the broadest one that I would like to see happen in more places, other than they're bringing, again, this set theoretic types to Elixir now, may just solve this. But being able to, and we'll look at some nesting examples later of how this really helps the style in Elixir in general, beyond thinking about functors and monads, right? It doesn't require you to change the style or idioms at all. This is entirely about data and how data relates to each other. So this is with Algae, how you would define a maybe, or sometimes called an optional. So you have your module here. This is the directly out of the code, because we shipped a bunch of common data types in the library. So this is algae.maybe. We use quark.partial for our partial application in it, so that's an import. And then we include these types. So it's either just.t, which is how in Elixir you typically call the type of a single type in a module just t, so just or nothing. And then we have these two modules, nothing, that has this struct inside of it, so def struct, has these square brackets, and then just has this one case. This is how you would This is the implementation, not the macro that defines it, which we'll look at in a couple of slides. But this is what it generates out at the other end. Type class. So as I mentioned before, protocols in Elixir are basically type classes that, or an interface that only you just define the one interface for it. They also have this thing called behaviors. It's a related concept, but we went with protocols because they're much closer to type classes. And I think possibly we took macros further than I've seen any other project do, at least definitely at the time. Maybe there's some more intense stuff now, but the macro code in this stuff is intense, right? So in general, the first rule of Macro Club, don't use macros, right? Unless you really have to. And we looked at it and we're like, yeah, we really do want these features. So we went pretty far with it. Type classes, even in a language like Haskell, can be unprincipled, right? So they might not have laws associated with them. So if you have something like a monoid, so this is a construction where you say, I have, let's say numbers, and I can add them together. So that's my monoid, and I can always add more of them together. The law there is that it's associative, it's commutative, right? I can understand algebraically how this thing should behave. There's nothing about type classes that enforce that. So we thought, what if we added that to type class so you could then describe your the properties that you expect it to have, and it'll complain at you if you have no properties, but you can then still tell it like, I'm just going to skip this, but like by default it'll complain. And then it'll automatically test them, it'll prop test them on all of your implementations. Some of this was a mistake, and I'll tell you specifically why when we get to some of the lessons later. But the overall idea of having protocols that can depend on protocols is a good idea. And in fact, I would like to see it in more places. This is how type classes work. This is how traits work in languages like Rust. It was actually really surprising to me that it wasn't in there originally. Around, maybe 2017 or so. So all of this stuff now is like pretty stable. The company that I was working at, running Elixir at the time, had outsourced an Elixir project to an external team that had never used Elixir before. And it was like months behind using Phoenix, the main web library. And so they called me in to like fix it as fast as I could. And I pulled in type class and actually had it working in like days. Now, would I recommend actually doing that? No, the library author, using their own tools to do this, but we were able to like really just enforce, hey, each of these controllers in the MVC needs to have exactly these things. And I'm just going to describe it with a type at the top, and it's going to generate for me all of the data types and all of the, enforce that it has tables that, work this way and all of this stuff. And we could have this class inheritance. And by class inheritance, I mean like a type class style inheritance. So there's super types, not subtypes, to manage all of that. It was actually, I don't know if I'd want to maintain that code, but it got us up and running really fast and shipping things out the door that we could then put into a more standard idiomatic style over time. So this is example. Top is what actually gets like a basic protocol, right? So this is the standard protocol thing for applicative. And then the bottom is how you would implement that, again, the standard way in Elixir, right? So we're generating all of this stuff out, basically, using type class. The only code that you're required then to write is this, just a couple small functions, and then the rest of it automatically gets generated for you using all the macros. So these are the properties that I was mentioning before. So in when you're writing a type class, you want to have all of these, and we call them spot check identity because we're going to then prop test them at the end. So in this case, we have identity composition, homomorphism, interchange, and functor as well on this one. And so it just automatically uses the implementations that come from the imported or from the constraints, because we know that we have them around now. You don't have to re-implement all of these things all the time. You know that you have a type that already has an implementation of this other thing. You can just keep using them. Hopping back to Algae, so looking again a little bit more at like what do these interfaces actually look like. So in Algae, we had def data and def sum, as opposed to def struct, which is the default. And this let us put types directly in the definition, and we could list them out in this more linear way rather than in the standard way. You basically say, hey, there's a bunch of keys and they look like this, and that's just in a list. Here we can say, yeah, I have name. So this is like for a character, clearly, in like a video game, name, hit points, experience, and they have these types on them. And we're using that double colon, which is like what Haskell has, right? You have this double colon syntax. Def sum lets you put together a bunch of these def datas. And we went relatively far with this, where there's a bunch of different variations so that you don't always have to crack open a do block. So if you see on the bottom, it's just a single line for each def data, so that you don't have to now have like multiple lines for each option in the sum. You can just list out a whole bunch of variants directly there. And then this one small block, which is 4 lines, including the end, generates out all of that code that I was mentioning before. So you get all of this stuff. You even get constructors out of it. So they have a new function, and generates the types for you, all of this stuff. You can even have it, it's not shown here, but you can also have it generate default values in your new. So you can put, I think it's, equals, no, sorry, // and you can put a default value if you want to have defaults in it. And then, so this is the classic maybe. So you can import in just a nothing. You do have to import them directly, so unless you want to have an import macro. And they work as you would expect, right? So now you can have this this add function that can fail into a nothing, and there we go. Adding 1 and the wrong type fails us over into nothing, right? Instead of having the try block on the left there, blow the stack. You can blow out of the unwinding the stack by throwing an error. Witchcraft, I would say, is the main show. In Elixir, you're really trapped in the IO monad all the time. There's no way to enforce purity because you're always, talking between actors, very side effect focused. Because it's such an async focused language, we didn't want people to have to always wrap things in tasks so that they would asyncify. So we just shipped variants. So we had map and async map. And there was also some subtleties around how you would want to wrap the task to make it more performant. And so we just shipped those as part of the library. So Witchcraft is what gives you actually like functors, monads, applicatives, and we'll look at that whole hierarchy in a moment. And we want to think about it like we're implicitly in IO all the time. So you're not again, for the Haskells out there, you're not doing map, you're doing map-m constantly, right? And there's a lot of differences in here from Haskell. Again, we had to sort of take the concepts apart, really understand them. So it's a good way of making sure that your understanding of Haskell is in depth too, and then recombine them in this more Elixir way. So as you see some of the code, some of it will look familiar if you come from Haskell, some of it will look less familiar as well, especially the piping order. So in Haskell, when you do application, it applies to the very end because of how the $sign works. In Elixir with the pipe, it ends up as the first argument. So, and in a lot of cases, that ends up being really awkward, and we wanted variants that were like renamed about where you're piping into. So actually the Haskell way is significantly more consistent it is. So we want to be consistent with the local language. What we don't want people to feel is this, you know, I mean, it's in the name, witchcraft, right? It should feel natural. You're doing functional programming in a functional language. This should all feel like a natural extension, right? People understand maps because they have enum.map in Elixir. They should understand functor.map. And in fact, functor.map should be even more convenient. There's some stuff about enum.map that I don't love. Like it always outputs a list at the end. I want to get back to the original data type that I was in without having to track manually, you know, what order my binary tree was sitting in or something, and then reconstructing it. This is something that drives me, I write a lot of Rust these days, drives me wild in Rust too. So this is an example of making, trying to plug into the intuitions and Elixir, and sometimes they're called alchemists, that an alchemist would have. So I have this anonymous function on the left side, and then I'm piping that over. So my arrows have to point the other way because we're thinking about pushing data this way over these three sets of arguments. And they're basically applying into position 1, 2, and 3. So this is an applicative, right? And then it generates out for me every possible combination of those. And so they're just sort of laid out here in that way. So this is sort of like your hello world for applicatives in Haskell. The arrows pointing gives you a sense of the data flow, but sometimes it's like here, it's a little bit awkward because it's not that you're piping a single function or a single bit of data, you're piping multiple bits of data, which would be unusual, but we're still plugging into that intuition around pipes because pipes are everywhere in Elixir. So Elixir prefers what's sometimes called diagrammatic ordering, so that you can write it out like a diagram like this, right? Pipes are awesome. I love pipes. I want pipes in more languages, right? So we kept telling people we're just giving pipes superpowers. So this is a map, right? So we've taken a single bit of data and now we've extended it to work on collections. And instead of having a vertical bar, we have a little squiggly tilde, and now suddenly it works on collections. And the rest of your function is the same. So you could still write pipe enum.map on each of these, but sometimes it's just convenient to just have, you can read it really quickly. Tilde means this. The downside of using operators for this is that there's a set number of operators in Elixir. So you're going to conflict with some other libraries sometimes. So we had to make sure that we could turn those off at import time as well. So there's an option to enable operators or not. And all of these are automatically curried, by the way. So that's how it pulls in from Quark. All of this stuff becomes curried out of the box. Operators follow the same flow as pipes. So this is, you know, the top in this example, 1, 2, 3 is piping over that function, but you don't end up thinking about it that way in Elixir like you would in Haskell, right? We're now thinking about this as data moving around. And we added basically more arrows to show that, or so if you see in this bottom left, the number of angle brackets basically implies how powerful that is. So we have map, you know, apply is the standard one, then we add a tilde, this becomes map, and then we have the applicative app and chain, which is basically monadic bind. At the bottom, we actually have a taller hierarchy than in Haskell. We also included arrows, which I mentioned before, I think were criminally underused because people want to do this data flow stuff. So you can write out this diagram and then just express it as compositions of functions and fan outs and unsplits and all of this stuff. And then I've actually did a project where we baked this down into Broadway. I'm not sure if Broadway is still the main library for this or not, but so that we could describe just the shape that we wanted and then actually have it be run performantly in Elixir. So functor tower, these are abstractions, they're well principled. The purpose of abstraction is not to be confusing, but to be really, really precise about what you're trying to do and to have it be understandable to somebody who knows these idioms. So here's the most of what ended up in Witchcraft. So there's a bunch of hierarchy in here, and this is where we're using type class to fill these out. And we're going to look mostly at this functor hierarchy, the thing that's outlined in this in that box. So functor, this is map. Most people are pretty familiar with this one. Works as you'd expect if you're coming from Elixir, enum.map and enum.into. So enum.map gets you down to a list with the elements mapped over, and then into, you have to turn that list back into the shape that you want. This does that for you automatically, and in some cases more performantly. Apply, we had to, this one was really awkward with the data flow because you're not often just piping a single thing, you're piping multiple things, right? So this embellishes function application, and we had to, based on the argument order, have convey and app and a bunch of these different things. Apply is already a function, so we weren't able to reuse that word. A bit challenging. Chain, which is just below monad, gives you this pipe operator. So this is essentially monadic bind through here, and it also does, just like with functor, you always stay inside that same data type. And so we're using Algae here to make sure that we know which data types we're going to end up in, yeah, it just flows through with this binding action. So if you're using the actual bind operator in Haskell, it's basically chain. And then do notation. So do notation lets you take this version on the top right and then make it look like this with these left pointed arrows at the bottom, where you're always just bringing values back in. And if you end up at in this case with the maybe, if any of them are a nothing, you'll get kicked out and dropped down to the bottom. And so we could actually, with the operators and the facilities offered in Elixir, we were able to create full-on do notation. You just have to say either chain or monad at the beginning. If you can imply if you're willing to actually write out just at each step, you can do it directly. If you want return, you would say chain just or monad just do. And now you can also put return along in it, which looks a whole lot like this. So here I have monad list. So I'm saying I'm in the list monad. I'm going to pull out of nouns, each of these nouns, adjectives, verbs, and reactions, and then return this Mad Lib version. And then we're going to generate out the version on the right. So this is, again, sort of like a hello world version of the monadic style on lists in Haskell, just expressed in Witchcraft. And so we actually had, like, again, other than having to say which monad you're in because of how the type system is just missing features, at least today, though now they've added some stuff to the AST that would have made this easier. You get the full, very, very close to what Haskell has in terms of syntax. And the implementation of this actually turns out to be really simple. This is the entire do notation implementation. So we're operating on raw AST here, but we have left pointing arrow, and each individual line then gets the bind operator, the chain operator in between. So it's actually not that much code to do it. Just as an example, for those of you that are familiar with this style, here's the writer monad. Looks, again, a lot like Haskell, where we're writing into this list, and we're returning, or into this tuple. And yeah, we actually used this for some logging in production as well. Yeah, another example is extending that previous one. You see logs down around the middle. We have pipes and then also binds in the middle, like chains in the middle. And so that gives you this ability to interleave the two. Now you're obviously working at different semantic levels when you're doing this, and you're not forced to stay inside of the monad, right? Because of how the type system works, but it actually ends up being relatively natural in feel. So lessons learned along the way. Build it and they will come. I didn't expect people to be as interested in this project as they ended up being. or for it to get as much production use as it did. People became interested in it over time, and especially projects that last for longer amounts of time. If you're writing a library, if it's just been around for a few years, people might be interested in it, or you give a conference talk about it. I gave a keynote at Elixir London, now called Codebeam, in London, and so that had a lot more use all of a sudden, and a lot of people that wanted to maintain it and get involved. But as a solo maintainer at the time, this was a lot of work, right? And so maintainer burnout is absolutely a thing, 100%. Something I've learned since then on other projects is to get people involved in it that might be interested in it, or even that want to learn, even if they're not a quote unquote expert in the thing, from day one. And like, hand off as much credit to them as you possibly can, right? It's not about having the glory yourself. It's about getting other people involved because you want the project to exist and it must be larger than you. I left this too long in Witchcraft. By the time a bunch of people wanted to help maintain it, I was just not there to really help onboard them into the project anymore. Prior art sections and readmes, strong recommend, right? At the bottom, just say, hey, here's other projects that are like this. Maybe you'd find those interesting too, right? If we want this style to happen, there should be multiple not even competing approaches. There should be multiple approaches. Call up the other people that are doing this stuff, right? Talk to them about their approach. We're all in this together. We want more of this style to happen, right? Haskell always said that they're about avoiding success at all costs, which has the two interpretations, like avoid being successful, right? But also, and stay in the academic track. But more importantly, avoid being successful at all costs and diluting the concept, right? We want to be, want these things to find their way into other ecosystems, into other areas. We want to help support other people doing this. And that's something that, as a maintainer, I just failed to do early on. All things come down to humans and governance, right? It's something that I've learned along the way. The other thing to note is that maintainership is different as a project evolves. So we actually took Witchcraft very quickly from something that is quite visible and like, using it as a teaching tool and like really innovating on how to bring these things into a new ecosystem. And then over time, it just sort of fades into the background of like, yeah, it's a dependency, right? And different people fall into different parts of this spectrum. And my career has basically been moving towards the left, right? So towards invention over time. And when you have somebody who's more on the invention side, they get bored. They don't want to write, 100 million benchmarks. We did in Witchcraft because it was the right thing to do. But this is also part of why the maintainership fell off a little bit. The other thing to note is that the further to the right you move on this spectrum, the more money there typically is for maintainership and sponsorship. So getting people involved early on that can then take it into companies that want to support it in the long term. Evan, the creator of Elm, talks a lot about this as well. So I'd recommend looking at his Strange Loop talk from 2 years ago, I think, about this as well. And also what this then enables is once you have that thing as a really solid base, like let's say, you have whatever type class is now really solid, that enables you now to go and do more innovative work again and bring in those people that are more interested in the invention side or the bringing things out of pure ideas into and popularizing them, right? And then it can, this cycle can continue over time and we can just get better and better, cooler tools. Also, final thing, if I were to approach this these days, I actually would have just put a type system into Elixir. There's this great paper, Type Systems as Macros, implements a system or shows you how to implement a system called Turnstile. I would have just put Turnstile in there now. My tastes have really dragged over into co-effect systems and capability systems. If you're not familiar with capabilities, I strongly recommend functional programming people to read Robust Composition by Mark Miller, especially if you work with the actor model. They are such an extension of the functional way of thinking, especially in a distributed context. So I would, and they have a very close connection to co-effect systems and types. right? You won't find that in robust composition, but like it becomes very apparent, I think. And I would say branding over time has become even more and more important. One of the things that gave us a boost for Witchcraft is that we had a cute logo, right? I worked at a company that had a lot of designers in it, and one of them was like, yeah, I mocked this up for you over the weekend. Do you want me to make it properly? I was like, sure. And that makes people think that it's like, more of a serious thing. And I would say that that's even more important today than it used to be. So anyway, that's the whole presentation. Thank you very much for letting me ramble about my 10 years of writing Witchcraft.
Thank you very much. Very interesting. Thank you very much, Brooklyn. And a very ambitious project also, making this happening. I mean, it's not just, I'm going to take this part. This whole part I'm going to bring into another language and build my own system. It's very ambitious. I mean, of course, I think it's, very ambitious. Still, we don't have any questions right now in the chat. However, we have one, like, shout out, like, super cool to hear about the project. We also had a shout out, like, totally recognize this maintainer burnout. You start something up and then all of a sudden you're like everywhere helping people and then you get burned out. However, I have a question. It's like, is Witchcraft used today in production? Are companies using it, or is it?
Yeah, so I'm not super sure how widely it's used today. I was looking at the stats while I was building this talk. It's still getting a couple dozen downloads a week, so somebody's using it somewhere. We did use it quite a lot in production. 2016, 2017, 2018, 2019 got a fair bit of use. There was sort of a small community that were using it and putting in things and having success with this. I was mostly you see issues in GitHub, but then I'd go to conferences and people would, that's usually where you hear about the positive sides of people stuff. And actually a few people also gave talks about using at other conferences, their use of Witchcraft in projects and basically trying to encourage people to use it. So I assumed that it was a good experience for them. But I don't know of any off the top of my head today that are using it in like a really heavy way. But it used to, at least.
You're working with Rust today? Are you looking into porting or doing libs in Rust? Similar to Witchcraft? Or are you already on it, maybe?
The last 5 years, I was running a very R&D focused company as the CTO. We built on top of Haskell, but we found that Haskell on the back end and for things like CLI tools and whatnot. And I would say actually that was a really great experience overall. The tooling in Haskell, not always the best, right? But like the actual writing the language, amazing. And we were able to hire people that were really passionate about Haskell. So the hiring story was like unparalleled. We had people asking us constantly, like inbound, which unheard of, right? It was like we didn't need recruiters or anything, right? It's amazing. And then Elm on the front end. But over time, we found we were writing more and more TypeScript because people wanted to consume it in, we're writing SDKs, they need to consume it in their own apps. And we started writing a lot of WebAssembly. And the primary language for WebAssembly is Rust. Rust has a lot of, obviously it's not a functional language per se, it's multi-paradigm, but it's, it's like the first class language for WASM. It is strongly typed. It gives you, like the borrow checker is, I'd love to have a borrow checker in more languages. It's once you learn how to actually use it, but you can also write in a very functional style, right? Maps and reduces and all of this stuff. They do encourage you to use, right? They call it a functional style. It's like functional-ish, right? Because you're always in IO. But yeah, mostly Rust these days. There are a couple projects porting things in to Rust, and they have macros as well. But they the core language is missing a few things. They don't have higher kind of types, for example. As soon as they ship higher kind of types, there will absolutely be monads in Rust, right? And you kind of fake it today, like in a similar way that we do with Witchcraft, but it's so far out of the idioms in what is already quite a large, complex language. Unlike Elixir, which is, I would say, actually a fairly large language, but really focused on developer experience. Like, if I wanted to say what the thesis of Elixir is let's make this really friendly. That gives me the headroom, right, for complexity to add monads into it. Rust, it's very complex already, right? So I don't know if people would necessarily want all that extra complexity in today. So no current plans, but there's some stuff in the standard library that is intentionally very functional already.
Yep. Final question from the chat. It's like, you seem to be into statically typed languages. Have you looked at Idris and taking it further with types?
Yes. So we did a whole session at the Vancouver Functional Programming Meetup about Idris. Idris 1, we implemented I implemented and showed off to the meetup a little web server. Idris 2, I haven't played with as much. Let me take a step back. I really, really, really love dependently typed languages. I think it's a really interesting approach. Idris 1 had this whole tactics language. In addition, it was a little bit in some places like you got a lot of power, but it was somewhat difficult to work with. Idris 2, I haven't played with as much. Like, I've looked at it, but not as much. I was involved in a conference last year called Causal Islands that actually brought Edwin out to talk about Idris 2. I chatted with him about that last year a little bit, and it was super, like, similar to this, right? Learning his lessons over time of like what he would have done differently and like how this all fits together. Super interesting. The language that I'm most interested in keeping an eye on in this space, though I don't think it's like explicitly like dependently typed in the same way, is verse. So I'm anytime something about verse comes out, which is Simon Peyton-Jones is working on this right now for Epic. I just voraciously read whatever I can as soon as they announce anything. So that's and because it's coming directly in a production system with some really, really innovative features and trying to make it familiar to people coming from C#. It's fascinating.
Cool. I will for sure check it out now. I haven't heard of it before, actually. I will check out verse now. Again, thank you very much, Brooklyn. Thank you for your presentation. And thanks for coming on and presenting. Very interesting. The audience loved it. Me too. Thank you very much. Now we will head over to our next presentation. And our next presenter, Edward De Jong. Welcome to Func Prog Sweden, Edward.
Thank you for having me. Can you hear me all right?
We hear you all right. Warm welcome, Edward.
Great. I'm here in Cairo for my son's wedding, and we had a power cut at 6 p.m., so I was panicked for a while. They do that because people come home from work and turn on their air conditioners and blow the fuses of the entire city. Anyway, thank you for having me. I'm here to talk about the Beads language. Beads language is a very odd language in terms of the landscape. If you look at most languages in their actual syntax and specification, they do not actually draw or handle events in the language itself. They're done through libraries, which are inevitably extremely dependent on the operating system. Other languages have some drawing and events built in, like ActionScript 3, which was what was in Adobe Flash. APL had some graphics. Dart and Flutter.
Sorry to interrupt, Edward.
Yes.
But do you want to make your slides into full screen? You can share them like this if you like. I just want to ask you if you want
No,
full
you're
screen.
right. That would be good. How do I do that?
That's a good question. Let's see. There's always somewhere. Present, maybe. Let's try it out.
Let's see. No, that's 2-page view.
You had present there. If you tap the menu again and you push present, I think you should be able to get it up.
Fit to width. No, that's not going to work. I posted this spreadsheet. Let me just talk it over. I don't.
Yeah, sure.
Yeah. On the right, yes. Present. Okay.
Oh,
Great. Okay. And then, okay. So most languages don't drag and draw. All right. So I've been making graphical interactive software for 25 years. And the problem now is that Google controls the web, and they have decided that we are going to program in HTML and JavaScript and CSS together, and maybe add some tools on top of that. And that is the only way into the browser. You know, the browser doesn't support any other. You can talk about WebAssembly, but it does not have the ability to draw yet, and it does not have control of the browser at all, really. So you've got to generate the, something in JavaScript. And, frankly, and never in history did people have to write in 3 different languages at once inside a file. Sometimes it's 4 languages. So I just couldn't stand it. So my goal was to replace that entire stack with a single language. And I want pixel precision, and I want it to be interactive, and I want it to be super robust and reliable, and I want it to be brief. I want it to be a shorthand notation for professional programmers, but I still want it to be able to be understood by other people. So I don't want it to be cryptic. I'm not going to use a lot of any one of the 600 Unicode arrows and symbols that, you would have to learn just like Chinese and memorize. So I wanted to maximize 5 characteristics at once. It has to be graphical and simple, robust, concise, and maintainable. And that is a very difficult set of simultaneous constraints, because if you want to be graphical, usually it gets complicated. And if it's maintainable, it may not be that concise. So there's a lot of compromises in here, and you will be the judge of whether or not I achieve these 5 things. This is a free product. It's an indie effort. It's in a commercially usable state. I'll show you some examples in a minute of commercial use of it. It spits out JavaScript in one file. So you have one HTML file, which is 99% JavaScript. And then for the server side, you just generate it as a node, as a .mjs file, which is the node, the suffix for a node file, which is just JavaScript running on the node.js interpreter, which compiles it just in time for the server. It's particularly good at client server because you can write in the same language for both sides. This is it's a dumb compiler. There's no fancy autocorrect or suggestions or anything like that, but it is at least fast. So you can say compile and it's under a second, and you don't need a make system. The way you code in this language is a little different. You're writing in small little chunks of code, and you have hundreds of these little blocks of code, and they're basically formed into a hierarchy that matches the structure of the screen you're trying to draw. And each block of code has a prefix in front of it saying what kind of work is that code going to do. Because if it's a drawing block, it's going to have an implied graphical context variable. And if it's an event handling block and tracking events, it's going to have the block it drew, and it's going to have an event handler. It's going to have an event record. And then if it's a calculation block, it can only calculate and is not permitted to draw. So you have those types of blocks. So you're tagging every chunk of code as to its purpose. And the reason for that is, well, I'll get into that later. One of the problems when you get into large graphical interactive products is that the event handling code is nowhere near the code that draws. And so when you are given a big complex product to maintain. Somebody says, here, take over this product, and it's 10,000 lines of code, and someone says it doesn't respond right when I click over here. It is extremely difficult to know where event tracking is going on, especially if you're dynamically adding listeners. You have to figure out who added that listener and where was that code that did that. So instead, in our system, in beads, you put the tracking code right after you draw that area. And every time you draw a rectangle on the screen, you own the events for that rectangle, and the event handler for that rectangle of screen space is immediately after the drawing code. And that forces you to keep your code in a sensible, maintainable structure. I wanted it to be robust. And one thing that I admire about spreadsheets, and I think it's one of their superpowers and why Excel is so beloved by business people. It may not be liked by programmers, but there are literally a zillion people using Excel spreadsheets. And why do they like it? They like it because it has closed arithmetic. That's one of the things that's special about Excel, is that if you have an undefined variable and you multiply it by 2, it propagates the undefined. Or if you have an error condition and you multiply it by 2, it still is an error condition. And so errors propagate through the system, but it never crashes, you see? And obviously there's a trade-off here. You're doing error checking on every computation. It's not going to be used for matrix manipulation or machine learning applications. One of the things that I think Excel forgot to do, that is one of its greatest omissions, is to add physical units of measure. And there's a language called Func that has every measurement known to man, and he is like the king of all measurement gurus. And that's where I got my fundamental constant values from, because he is actually now the curator for the entire world of those numbers. And but you can say 3 kilograms plus 2 pounds plus 3 ounces plus 1 gram in the syntax, because it has all the conversion factors of all the common physical units built into the compiler and runtime. So, and you can create your own units. So you can say, what's a furlong? A furlong is 220 yards. And then in your code, you can use a furlong from then on. I never use this. I built it for engineers, but engineers are very stubborn and they don't like to try new languages. So, but I did it anyway, and I think more people should add units of measure to their languages. I don't like regular expressions. So I tackled that and I said, let's take that regular expression that in JavaScript is one cryptic line, and let's break it into a vertical structure where you can have comments per section and use English words, keywords, for boundary and how many, 1+ quantity. So we made it easier to read, and you can actually understand someone's regular expression in this syntax. It generates the same exact final regular expression, but it's just it's a more readable notation that permits comments, and that is one of the better part. You know, it's a clever part of the programming language. This is where it really starts to diverge from almost every other language. There are no objects or RAM pointers in your program. So you have a tree system, you have a model in your code, and it is a hierarchical tree with crosslinks, and that is basically a sparse graph. It's a sparse n-dimensional matrix, which you can think of as a hierarchical tree with crosslinks. Anyway, the arrays can have numeric and string subscripts. That's the same as JavaScript, actually. Arrays have kind of a strange indexing system in JavaScript. And because we're not using memory pointers to an object, but rather a path from a starting point in the hierarchical structure, it is actually valid and can be saved onto the hard drive, loaded back, and sent across the network. And if you're sharing a subset of a tree, of a database, in the server, then you can actually have a valid pointer across machines. So that's something you do not see very often. Java, you can't send a pointer to another machine because it has no meaning, because it's a RAM address. There are no closures in these, but we achieve the same function by having what I call a frozen function call. And what you do is you save the parameter list with the address of the name of the function, and then later on you can call it. All right. No physical address, no closures. This is a big part of the language. 30%, a third of the language is related to drawing and layout. And this is where CSS is very weak. CSS has both an inside out and an outside in model that can be baffling, because if you put too much stuff in the middle of a block, it will push out all the other blocks around it and scramble your layout in a baffling way. This system we have is you are always subdividing from the outside in, so it is 100% consistent, repeatable, and there's no surprises. The other area where CSS, I think, blew it bad is they used implicit white space. So you say what your objects are, and then you tell it how to position them relative to each other, and then it tries to interpret your desires and then puts them out maybe in the way you want it. What we have is explicit white space. So we say, put this box and skip 3 points of space, and then put another box. And so you actually tell it how much space is in between the blocks, so that you are telling it always what you want exactly. And that way you get what you want. And this comes in very handy in mobile devices where you need real precision. Another area where drawing is a pain in the rear in the web is that oftentimes you have sizes specified, but depending on the kind of screen you're on, that size may be too big or too small. So what we have is you specify sizes as proportion of the height of the box, usually, and you can also have it, by default, it auto sizes, and if you overdo the text, it will shrink it down. So it's expensive, but boy, does it really pay off in when you're switching languages. German expands word length by about 28%. So you make it perfectly great, perfect in Svenska, and then you switch to Deutsch, and and all the words are spilling out of the boxes. So this is a handy little feature. Because I have this kind of directed graph as a tree, and that is your model, every node can have a value and children. And beyond that, there is a secret timestamp on each node of the tree. And the runtime is keeping track of when you have changed some aspect of your model. And this allows us to do something later on about refresh. Every time a drawing block is executed, the runtime is keeping track of what part of the model it looked at when it was drawing. So there's no other language that I'm aware of that does this. So this is a very intrusive thing. I'm actually saying every time I look at the model when I'm drawing, I'm going to remember what I looked at, and then 60 times a second, the runtime is seeing if the model has changed, that part of the model has changed that you looked at. Because if it has changed and you drew it, then you've got to be redrawn. So this is an automatic refresh that will guarantee that you sufficiently refresh the screen, and it approximates an optimal refresh. This avoids a whole class of bugs in graphical interactive software that I'm not aware of any other language addresses, which is, how do you know that you've redrawn enough of the screen? Now, in 3D graphics, you redraw the entire screen 60 or 120 times a second. That's because you have a GPU pounding on these graphics chips that does that for you. But that's not how the web is done. The web actually has a character textual, hierarchical textual representation of the screen that is then converted into pixels. And so when you change the document object model in the web, you have to emit basically character strings. And you should not change those character strings because it'll cause a re-render. So there's a lot of systems that re-render and then compare, but that actually is very, very inefficient. So this is a much more efficient way to do it. And when you get into client and server, we allow you to subscribe to a section of a model, and it will automatically transmit the new any node that is changed in the model is sent in binary form across a communication channel automatically to the client. And when it's finally downloaded, it will then instantiate it on the client. So the client is always in a valid state, is updated as fast as it can be, and it does not have to do any message passing or encoding or decoding. Just a ton of JavaScript programs are constantly packing and unpacking JSON strings. We don't do any of that. You can do it, but it's obviously less reliable than letting the runtime do it for you. Now, does it work? Yes, it works well. And I'm going to show you some examples now of this is a mortgage calculator. Now, this is a very dumb application, right? This is something that's very simple. You're going to enter your price and your down payment and the rate and how many years, and then it's going to tell you how much your mortgage is. And you can add the taxes and fees. And this is typical for, a tiny house in California. Might be 500,000. The tiniest house, a shack. Anyway, this is on a regular screen. But if I click in Google Debugger to toggle the device, this is what it would look like on an iPhone 12 in portrait orientation. And if I click it on landscape, it flips it and it's still legible. So the idea of this code, the reason you would use beads is you want to be compatible with both mobile and desktop and tablet, and you want a simple notation, and you want it to look good on all those devices because it will stretch. Now, here is an example of a dynamic layout where I'm adjusting the window size, and the screen is going to rejuggle everything to fit. And it's going to fit as many as it can on the screen. And I specified a certain thing. Now, here I'm clicking on this column 2 box where it says A equals 10, and it's updating BB. So let me show you why. This is where the automatic update comes into play. If I go to the code, so remember we talked about how at the beginning of the code, you write your schema, you write your data, your model, and you say in a strongly typed language, what is the data types and structure of your model? In this case, I have three numbers, A, B, B, C, C, and a banner, which is a string, and that's my model. And I've declared a variable, the interface, which is gonna be of that type. And then main init is going to be called once in every program, and that is your one-time initialization program block. And then main draw, and that is the entry point. So what we're doing now is we're saying this block, main draw, what kind of block is it? It's a vertical sliced block. So it's a columnar block where I am going to make blocks. I'm going to fill it with a blue color, and then I'm going to add the banner as a slice at the top. And it's going to be 30 points high. A point is 1/72 of an inch. It's about 1/3 of a millimeter. And that is it's a convenient number to do typographical things in. It's the long, for hundreds of years, it's been the standard in typography to use points because it's got enough precision for the human eye, but not too much precision. Anyway, And then I say add the remainder space, 10 aliquots. Aliquot is basically a proportion. And it's saying 10 units of proportion to the remainder. So what I've done is I've split the screen into two parts vertically. 30 points for the banner, where I'm going to say banner is here. And then the remainder is this lower section. So this is a domain-specific language where I'm adding slices to a box, and I'm subdividing the screen. And if I go to the, I have a 130-page user manual that you can, that I have on the Discord group. This is an example of the model. This is your data model. You have a node called C3, for example, that has 3 subnodes with values 11, 12, and 13. And then of 13 has children as well. This is different than Lisp and many other languages where your children do not have, you either have children or a value, but in beads, you can have both. And that allows you to go into subdivisions. And the subscripts can be both numeric or a string or a symbol, which is basically an enumerated number. Anyway, you do, and we have tree operations because now that you're operating with whole subtrees, you have kind of a different kind of assignment statement and so on. But back to the screen. Let's go back. Let's go back to another example. The color picker. This is an example of a color picker that I wrote, and you can download it and use it. And when you pick on a color, it copies the color name to the clipboard in any one of the 7 formats that people have asked for. If you were programming in C, you might want it as a hexadecimal number. And if you're programming in HTML, you want it with a # in front and then 6 hex digits. And if you're doing 3D graphics, you might want it as a vec3 as an RGB fraction from 0 to 1. So this program, every time you pick a color in this middle section, it then goes to the bottom and shows you a few hundred of the nearby colors in the color cube. So this is a production, useful product that a lot of people use to pick colors. And it was written in beads, and it would be very difficult to write it shorter in another language because it's resizable. I can change the size of the screen and it will constantly readjust into a nice format. So it's always trying to be legible and good looking and fill available space efficiently. So it's trying to use all the space you give it and still be legible at all times. And that's why you would be interested in this language. Oh, I got to build something for the web, and I'm going to need to make it work on mobile and desktop and tablet, and I don't want to have 3 versions of my program, and I want it to be simple. That's why you would use this language. If you're not doing anything on the web, then this language will be of very little interest to you. Let's see if I can get to the dividing of the screen. Here we go. So in this case, in that test 1 program, the first thing I did is I have an undivided rectangle. The second step is I divided it into 2 slices by saying I take this thin sliver at the top and then I have a remainder. Then that remainder is subdivided into 3 vertical sections. So the way you build every layout is by taking this undivided rectangle and then continually subdividing it and doing that over and over again until you get down to the tiny part of the screen you actually want to draw something in, like a button or a chart or a number or some text. And that is how you proceed. And you do it by proportion. So you might say column 1, column 2, and column 3 are the same width. you don't say how big each column is. You just say they're proportionally relative to each other. And you can specify sum as an absolute size in points. And then it will first subtract that absolute dimension away from the available, and then subdivide what's ever left over. So let's go back to this test case. When I click on this 100-point button on the left, you can see the A, B, and C are being refreshed. So if I go to the source code for this code, and I look at column 1, and I see column 1, I'm drawing column 1, and I fill it with aquamarine. That's that light blue color. And then I say, draw it, and I convert the width from dots, pixels, into points. And then I say, at 30 points high, draw with a style S text. That's drawing that string 100 point. Then it says track EV tap. So when a user clicks, or a mouse tap, or a finger tap in a touchscreen environment, it's going to increment the interface A, B, and C variables. It does not schedule a redraw of anything else on the screen. It's just changing the model. But column 2, if we look at draw C21, it is drawing the value of AA. So last time it drew, it remembered that it used AA. And because someone has changed AA by tapping in this left column, now column 2, this block C21 is going to be redrawn. And in fact, it's going to redraw 3 different blocks based on this tap. Now, another advantage of this system is that if we look in the debugger, in the Chrome debugger, for the elements on the screen, and I say, okay, this is a div, is a subdivision, right? And if I go into column 2, and I go and highlight this middle one, which says 28 right now, you can see that its ID is called draw_C22. Okay, so I go over to the code, draw C22. There is the block of code that drew that section. So this is giving you reverse mapping. You can see from the screen which part of the code drew it. And I got to tell you, that is not so easy to figure out in a lot of languages, especially TypeScript. TypeScript does nothing for you in this area. There's no help in reverse mapping in JavaScript or TypeScript. Because remember, TypeScript just compiles to plain JavaScript. So it's not helping you find the code that you're trying to fix. Like if I want to change this bottom block and I don't like that color, how do I know what code drew that? I can see from the Chrome debugger that this is draw C23. And if I go to C23 and I say, you know what, change that from dark orchid to black, right? And I say black and I save that. And then I go to the compiler and I say compile. And then I refresh my screen. Well, I didn't, I'm actually running on a different, hold on for a second. I was running off the web. There we go. Localhost. What did I do wrong? Oh, sorry. Did I not save it? I'm running off the wrong source code. Hold on for a second. I was downloading it on the web. Let me go back to the editor. C22, C23, still dark orchid. Okay, so I've changed it to black and I compiled it. And then if I go back to run it, there it is, it's black. So this allows you to build your product in small stages, incrementally, and you're always building on something sturdy. You start by declaring your schema, you initialize your data, you put in fake data, and then you start drawing the parts of your screen until you have it all drawn correctly. Then you get rid of the fake data and you take the real data maybe from the network or from user input. And you proceed in a very systematic way to build your product. And because you're only changing one tiny piece at a time and debugging it immediately, you will eventually get to a very sturdy final result. The other advantage of this syntax that, let's go back to the presentation. Can't find it. Okay. This system, by the way, the pattern that we're following in this language is the state action model pattern. You have a state, you do an action on it, and then you refresh it. That's the subdivision. That's the subdivision. Okay. We did this example. There's a real-time status monitor for the company I work for that is a client server product that I can show you the source code to, where we are checking every 30 seconds for the status of the 24 hardware nodes that we're running. We have 1,000 virtual machines running on 24 hardware nodes, and we want to make sure that those nodes are reachable because we have a backup, a hot spare running in a different city, and we want to know if things are still up. The percentage of punctuation, the readability of a language is very much determined by, in my opinion, by what percentage of punctuation you have. Perl is the worst. It has 39% punctuation. So if you take away spaces and you compare alphabetic characters with punctuation, symbolic characters, Perl is the worst. And Perl has a reputation of being a write-only language. And Beads is absolutely down there in terms of low punctuation. And that is a virtue. If I go back to the code, you can see if you just scroll through it, and I can show you larger programs, this grid has 1 indent, 2 indent, 3 indent. That's the maximum. But the average nesting level of the code is under 2. If you do a numerical simple and you say, count up all the lines of code and measure what level of indenting is that code, what level of nesting is that code resting at, you can see that by breaking your code into small chunks, which are in a hierarchy, but each code chunk tends to be 3 or less in the nesting level. And that means overall, you're never going to be lost in a deep nesting. This was the drawback of Lisp, was the nesting level was super high. Anyway, I've run through this thing rather quickly, and and I'm hoping that the people who are interested in using this will contact me, and we'll make sure that you get the compiler and the documentation. I have GitHub repository where I've posted most of this stuff. But the installation of this type of product is always a little tricky because Google does not, by default, does not allow you to load your own local JavaScript files. It actually blocks you from doing that. And it's bizarre that it does that, but you have to create a fake web server on your own machine to serve up your own JavaScript. Otherwise, it will say, oh, it's a security violation. So web development is it's kind of perversely complicated. And I'm not sure why they want it to be that way, but that is the way it is. So I guess I will go to the Discord and, oh no, sorry, the Zoom, and go to the chat and see if there's any questions.
Thank you very much, Edward. Thank you very much for your interesting talk. Where can people find beads? Can we share some links, or should they contact you to get it?
No, it's on. If you go GitHub and you say beads language,
yeah,
you can find it. Let's see if I have. Let's see. That's. If you say GitHub.
Yeah, there you have it.
Beads language. Why does it say Kang? Oh, well, that's not going to work. All right.
Yeah, look, there it is.
Okay. And then there are many examples of, and there's the source code for the color picker. I recommend looking at that because I paid Mark Ferrari, who's one of the greatest pixel artists alive today, who did most of the LucasArts masterpieces. And he picked that color palette. And, I probably spent 1,500 euros on that. So it's worth studying just to see the colors and how he selected them.
Yep.
Anyway, yeah, that's where you can get most of the stuff. And like I said, the compiler, you have to, it is available for Macintosh, Windows, and Linux if you use Wine, which is the Windows emulator.
Okay. Next question from a guy in chat. Is beads intendentation sensitive like Python?
Yes, it is.
Oh, okay. So will you auto format the code? I think Python does that for you today. You auto format the code to certain intendentation to work, or
you can only use tabs and to indent. No spaces are allowed in the beginning of a line. So we ended the stupid Python battle of whether it's 4 spaces or 8 spaces or 2. And it's like, no, you have to use tabs, period.
Okay. Yeah.
So we guarantee 100% compatibility between people so they can share code. Because that drives people in Python crazy.
Oh, yes. Absolutely. Then let me see if there's more questions. Otherwise, thank you very much, Edward. And if you want to ask more questions to Edward or to Brooklyn about what they presented, please head over to the Discord server and you can ask.
Oh, I would like to say one thing before.
Yeah, sure.
Is that
do it?
I was an undergraduate at MIT in. I've been programming now for 54 years. I started when I was 16 on an IBM 1620 punch card machine. And then I was at Jet Propulsion Lab and then Caltech. And then I went to undergrad at MIT. And I was working for this hotshot professor at the time. And because I was lucky, I got to attend a lecture by John Backus. Now, John Backus is not only the inventor of Fortran and a Turing Award winner, but he is the inventor of functional programming. And he presented his functional programming language in 1973. It was called RED. And he was at IBM Research Labs, and he was visiting all the universities around, the United States and possibly the world to present his new invention. And he gave an hour lecture, and I was in the lecture, and he told everybody that he was this new language, you would not be able to change a variable once you assigned it a value once. And the professors in the room at the end of the lecture came out shaking their heads, saying this man is a madman. And they absolutely hated the idea.
Yeah.
And functional programming, although he gave it a shot, it bounced off the wall hard and did not make a dent. But a few people in the academic circles embraced it, kept it alive, and have grown it into, to so large that you have a Swedish functional programming group.
Yes.
But the real intention of his, and if you read his Turing Award lecture, if you go back and read Backus's Turing Award lecture, which, by the way, they gave him a ton of crap about, because they thought it was an advertisement for his system, and they thought it was very crass and commercial of him to do that, to talk about his product, right? In his Turing Award lecture. You're supposed to just thank your peers, right? But here he was talking about his product. But the thing is, what he really wanted was interchangeable software components. He wanted to make Lego bricks out of code. And the problem that functional programming evolved into is it did not build interchangeable parts. And so this project, which I've already put 4,000 hours into, is trying to make code into Lego bricks. It's not graphical coding yet. It's still textual, but that we can address later in another generation of the language. But it is trying to make things out of small pieces of code that you could share with other people and that can still fit together, because the data model is very flexible. I'm not using tuples, arrays, lists, queues, and I don't have 22 data structures which are incompatible with each other. I only have one fundamental structure, this hierarchical tree with crosslinks, which means that everyone is sharing the same data structure. And I think that really we need to go back to Backus's original vision and try to get functional programming to what goal was, which was interchangeable parts and simple. He was trying to make something simple and interchangeable, like Lego. I mean, Lego is the greatest construction toy that was ever invented. It's almost 100 years old now, and it's still the world's best construction toy. Every kid loves it in every country on earth. And there's museums, amusement parks. What other construction toy has an amusement park devoted to it? None. Okay. And actually, there's multiple Legolands, right? So we need to simplify programming, and that was my effort in this. And I know that this looks kind of simplistic and dumb to you, but it is trying to simplify things. Because if we don't simplify things, we're going to collapse from the weight of all of these abstractions that we've built. And so that's my hopefully amusing anecdote about the great John Backus.
Thank you very much, Edward. Thank you very much. And also, I never heard of Backus, so I will check him up. And also the red language, I never heard of that, so I'll Google it away and try to find some more information about it. So
just look at his Turing Award lecture.
Yeah.
And you'll hear about it.
Will do. Thank you, Edward. And thank you, everyone, for joining tonight. Thanks to both presenters and everyone joining and looking at us live. For those who would like to ask more questions or have thoughts, want to share stuff, get onto Discord, the Discord server, and you can join and share your thoughts or ask more questions to both of the presenters. So with that, thank you very much, and good morning good afternoon, or good evening to wherever you are in the world. Bye for now.